Hello everyone, in this video I'm going to use tech sales data and I choose the hardware industry because in the assignment I ask you to choose a software with a college degree. Here I'm going to use hardware with the college degree as a sample case. So the first step is asking you to regress salary on 3 different models and summarize your results in a table. So you can see the table on the screen. Which I do is I just copy paste the table from the handout. So the first model is composed of intercept, age, gender, years, and certifications. And as you see, all these variables are numerical, so we don't need to transform anything. Just for your information, if your variable is string, the regression is not going to work. What I mean by string, text is a string. For instance, the personality type you see on the screen, diplomat, explorer, analyst, sentinel, we need to convert this variable into a numerical variable so that we can use in the regression. In the second model, we need to use this personality type. Therefore, we need to create dummy variables. And when we create dummy variables, we are going to use analytic solver. Solver is going to create 4 dummy variables, 1 for each. But if you remember, in regression, you can only use 3 dummy variables, not 4. If you use all 4, then you'll have the multicollinearity problem. And model 3, you are going to add the feedback, which is again another numerical variable, so no transformation is needed. First, let's transform the personality. In order to do that, you are going to click data mining, and then here transform, and you choose transform categorical data and create dummies. So first we need to select the data. To make sure we select the data correctly, I'm going to just choose the data again. And first row contains the variables, and I want to transform personality. And now the solver is going to create a new tab called encoding. So when you scroll down, you are going to see that there are 4 new dummy variables: personality underscore analyst, personality underscore diplomat, personality underscore explorer, and personality underscore sentinel. And I ask you to use the first dummy variables for your regression. So I'm going to just copy these numbers by Control, Shift, and arrow down and paste them into my dataset. So insert a copied cell, shift cells to the right, and now you have the new variables here. So from now on, I'm not going to use personality. I'm going to use personality dummies for analyst, diplomat, and explorer. If you want to change the format of the cells, you can just choose any of the cell here, Excel cell, and then format, copy, and then format. So let's order the columns so that we can run regression easily. So what we need age, but first our y variable is salary. So I'm going to cut the salary and paste it here. Salary, age, gender, which I have female, years, and then I need certification. So let me cut this one and insert here. And next, I need the 3 dummies for personality types, cut them and insert here. And I need feedback, cut and insert here. What I'm going to also do is I'm going to rename this dummies. The first one is going to be analyst. So this dummy is going to be 0 if the person is not an analyst type, and it's going to be 1 if the person is an analyst type. And I will do the same thing for diplomat. And now explorer. So now we are ready to run the regression for 3 models. So let's start with the first one. We need intercept, age, gender, years, and certification. So our predictors are age, gender, years, certification. Our Y is salary. So we click on data, data analysis toolpack, and then choose here regression. And the Y is going to be salary. Click on salary, Control Shift arrow down is going to select the salary. And now for input X range, for the first model you have age, gender, year, certificate, Control Shift down. And labels in the first, so therefore you need to click labels And here you can have the results in a new worksheet. Let's do it like that and call it as model 1 and then click OK. Now you can see the parameter estimates here, and also you can see the p-stats. Okay, one common problem is that when you have this ease, you don't know what to do, but this is very simple. You just need to format cells, right click, and then here choose number and make the decimal 3 places and click OK. So you see all variables are significant at 5%, because when the p-value is less than 0.05, that means you have significant. When we say significant, that means they are good predictors. They are good predictors in the sense that they are helping us to understand the variations in the salary. And what else you can change? You can change this one too. You can have, for instance, here only 2 decimals if you want, okay? And also these stats, you can make changes here. You want them to have maybe only 3 decimals. So it's all up to you. You can make changes here. You can reformat your significance level for F, and again number and 3 decimals, and click OK. So after we make these changes, we can fill out our table here. But let's estimate all the models and then we will fill out. Our second model, you need to have the personality dummies too. So choose data, data analysis, regression, okay. And here I need to change the X range because I've already selected Y range, which is my salary. And I want to include, this goes until I certificate. I want to include J, K, and L. So I'm going to change this I to L. So labels in the first row, that's why I click on labels, and worksheet, let's call it model 2 and click OK. Now you have the second model here. And again, we can rearrange the numbers. P-values doesn't look good. Let's change them, format it, and choose numbers, and then click OK. If you want, also, you can have 2 decimal points for each. And here you can also arrange, and you can have 3 decimals. Let's change significance F, format cells, numbers, and 3 decimals, and click OK. Next, I'm going to regress third model. So again, data, data analysis, toolpack, regression. And only thing I need to do is to change the X range, including the feedback. Therefore, L needs to change to M. And this time I'm going to call this model as model 3 and then click OK. So I have model 3 here. So I have the 3 models estimated here. The next step is we are going to fill out this table. So how we are going to fill out? We are going to fill out first here. I can show you a couple of them and then you can continue on your own. For intercept for the first model, let's go to the model, and intercept is 43,100, 3.09. I'm going to copy this cell and then it's going to take time to fill out this. Okay. And here now you have the coefficient estimate, but you can get rid of the decimals if you want. Either you can round this number or I just delete the decimals, okay? Having less decimals is more tidy, that's why I'm doing that. In the parentheses, I'm going to have the p-value, okay? P-value of the intercept. So therefore, this is going to be 0.00. And as you might guess, this is very significant at 5% level. Therefore, I'm going to have a star next to the coefficient estimate. So the star represents the significance at 5% level. So you will have a footnote under the table saying that star shows that the parameter estimate is significant at 5% level. So somebody looking at the table can easily detect the significant parameters, okay? That's what you are going to do. So this is model 1. You are going to fill out for all these predictors. And next, you are going to fill out their goodness of fit measure. Let's look at model 1. For instance, standard error is this one. So we copy this number and plug it here. And there are again too many decimals. I don't like it. You can just round it up if you want. And that's it. Okay, so you are going to plug R square, adjusted R square. For F test, let's do the F test together here. The F is 917.4128. So let's copy this number here. And again, too many decimals, I don't like it, I just delete them. And now the next is the significance of F. When you look at model 1, the p-value or the significance of F is 0.000. So that shows how significant our model altogether. So there are individual parameters you need to check for significance, but also you need to check for the significance of the model. Again, at 5% it's significant, so I have the star and I also include the p-value. That is how you are going to fill out the table for model 1, model 2, and model 3, and that table should be in your paper. So let's move on. The next thing is we need to select the best model. So if you remember from my videos, to select the best model, you are going to check adjusted R-square, standard error, and F-test. First, let's check model 1 adjusted R-square. It's 0.324, model 2 0.422, and model 3 0.547. It's obvious that model 3 is much better than the others, so the best model is model 3. Please do not forget to evaluate standard error and also F-test that supports your decision in your paper. And after this step, after you select the best model, for the following steps, step 3, step 4, step 5, you need to use your best model, not all 3 models, your best model. So our best model is model 3, therefore we are going to check for violations of model assumptions in model 3. So how we can do that? It's very simple. So we run model 3, but I'm going to run one more time because we need the residuals to check for the violations of the assumption. I'm going to use regression. I've already selected the variables and I'm going to say model 3 with residuals. And then this time I'm going to select residuals and then click OK. So here I ask you to check the graph of residuals and the predicted salary. So as a residual output, Excel is providing predicted salary and residuals. What you need to do is you need to insert a graph by selecting 2 of the variables. So how you can select faster, select this, 2 of them, and then Control Shift arrow down, and here insert, and then insert your residuals. Okay, so what we see here, I have many questions about how to interpret residuals. So let me show you maybe one residual graph that we don't have any violations first, and then we can understand what is happening. So on the screen you see a case where residuals do not violate any of the assumptions. So what is happening here, if you realize that residuals are equally distributed around the x-axis. Half of them are above and half of them are below. So what other patterns you can see in the residuals? You can see here one residual plot. You can find this Excel file on the course web page. This is for model assumptions and common violations of model assumptions. You can also watch, I highly recommend first you watch this video before you answer this question. So there is a significant pattern here. As you see, residuals follows a pattern, decreases and then increases over time. So this is a violation. Changing variability is another violation. So what you see here is that residuals are on x-axis, but then they fan out, right? So therefore, this is another violation. For correlated observations, you need to check residuals over time, but for this data set, we don't have a time series data, so you don't need to check for residuals over time. You can skip that. So given this, our picture, residual picture looks like this, right? When you look at our residuals here, you see that residuals are on x-axis, but then they fan out, okay? For that reason, changing variability is a problem. I'm not asking you to correct this problem, but I want you to explain how you can remedy this problem, what type of problems that this changing variability can create in your estimation. You need to explain that in your paper. So that is step 3. Next one is checking for multicollinearity, okay? I ask you to check the R-square and F-stat and determine multicollinearity may be an issue. Let's look at our best model again. We have an R-square of 0.548. It's not too high. Okay, if you have an R-square like 0.8, 0.9, you might think about multicollinearity, but I'm not saying that you will have multicollinearity with high R-square only. If you have high R-square, significant F, and some of the variables that you expect to be significant in the regression turns out to be not significant. For example, for salary, you know that years, which represents your experience, should have an impact on the salary. And you expect that when you have more experience, you will earn more. But if you find years insignificant in your regression and you have a high R-square and F significant, then you might have the multicollinearity problem. The second thing you can look at for multicollinearity is the correlation matrix. So for correlation matrix, you're going to check correlation between your predictors for your best model. So what predictors we have for model 3? We have age, we have gender, years, certification, analyst, diplomat, explorer, and feedback. So click on data, data analysis, and choose from here correlation. And the data range you're going to select starts from age, not salary. Don't forget all the predictors, not your target variable. Control Shift down. And labels are in the first row. And you want a new worksheet. Let's call it correlation. And then click OK. So now you have here correlation. So let's check the correlations between variables. Age and age has to be 1. That's true because it's the same variable. Age and female, not significant. Correlation is between -1 and 1. So when you get closer to 1 and -1, you have a high correlation. But if you get closer to 0, you don't have correlation. And I don't see any of the variable close to even 0.5 or -0.5. The highest correlation I can see, if I'm not wrong here, is this one, -0.5787. Still, it's not that high. Okay, usually we are suspicious of multicollinearity when you have a correlation more than 0.7 or below -0.7. Okay, so correlation is not an issue for this dataset. So next, you are going to test the significance of coefficient. Again, you need to do this for the best model. And here, you can see that p-values are very small. That means all these parameters are significant except analyst. You see analyst is 0.529, and if it's our significance level is 0.05, which is 5%, then this p-value is much greater than 0.05. Therefore, this personality type is not significant for predicting salary. So this is all about regression. I will do second part of this video, which I will talk about logistic regression.